Okay, so you're live. Please go ahead.
Okay. All right. Thanks, everyone. Can everyone hear me okay? I guess that I think that says yes. All right. So my name is Ton Ngo. I'm with IBM, and I'm located out in San Jose, California. I'm at the IBM Silicon Valley lab. Um, so I am a core team of the for Magnum, and today I'll take you through some details on the Magnum project. Okay. So I'll take you to some chart. Some of the chart are actually borrowed from our PTL agent Otto. So the chart that I borrowed from him, you see the credit for him there. Uh, if we have time, I'll try to do a lab demo. And unfortunately, my laptop just crashed just before the, the talk here, and I had to restart everything. So hopefully, if we have time, then we can get to the demo. If not, then in the chart there is a link to a video that was made by Adrian Otto, and you can view that as well. And that should show you a pretty good view for what you can do with Magnum. All right, so let's start now. I'll start by giving some of the background. And so the first question is, what is Magnum, right? So Magnum is a container as a service in OpenStack. Now to start, we can ask the question of how can you create container in OpenStack? And it turns out there's a number of ways you can do this. So the chart here shows a couple of ways you can create container in OpenStack. First is that there is a Docker driver for Nova, and if you install that Nova driver, then what you can do is to create a container, Docker container that kind of feel like a VM, and so that has been there for about a year now and work okay. We'll cover that a little bit more later. The second method is a heat Docker resource, and this is where you have a resource in heat that you can create, and it will interface to an existing Docker client, and so that you can create container and so on. And then third, there's a heat software config that lets you create containers through that look like a software config. So the purpose for heat software config is to install and configure software. So basically they are leveraging this existing feature to let you create and work with container. Right, and then now the problem with those three methods, as I mentioned in the last column, there is that they're not perfect, and there are issue with those. So with the problem we have been having with those existing methods, then the question arises that can we do better? So that brought us to the last method at the bottom there, the Magnum. And Magnum is a new project in OpenStack. It's been around for about a year, so it's a fairly young project. And so the purpose of Magnum is to bring container into OpenStack as a first-class object. Right? So now to create container, then you have to create the engine that drive container. So Magnum also let you create and manage the engine, and you can work with the container. So those are the kind of the background. Now to step back a little bit, when we start to look at container, then the first reaction is that, oh, it looks like a VM, so we can just treat it as a VM, and then it's nice and simple, and then we're done, right? So that's how the Docker driver for Nova came about in the first place. So it used the abstraction of a VM to let you create container. But after we used that for a while, then we realized that it's not quite the same. The container is not the same as a VM. And if you step back and look at it, then you realize that a VM is an abstraction for a physical server, whereas a container is an abstraction for a process. So they work differently and they behave differently. So there's a little bit of an intersection in the kind of things you want to do with them, and then maybe you can create and delete them. But that's about it, right? Other than that, they work quite differently. So that give us the motivation to treat container as something other than a VM, as its own thing. Right? So that gave us the motivation for uh, uh, creating a way to work with container as a first class object. That's how Magnum came about. And over time, as we build up the support for container in OpenStack, we found out there are many other things that Magnum can bring value. So this is a chart that we show the key feature that have kind of uh, give the rationale for Magnum. So first thing is that the Magnum bring the multi-tenancy for container, meaning that you allow more tenant to be able to leverage the OpenStack resource, OpenStack services without having to worry about the interaction between the tenant. And the second point is that Magnum bring the deep integration with the rest of the OpenStack service, namely it allow the container to use all the OpenStack services like storage, compute, networking, and so on. The third point is that out of the box, you can create different kind of engine to host your container. And right now we have support for Kubernetes, Swarm, and Mesos. So with Magnum, you can right away create this kind of engine to host your container. And third point is security. This is a key point for Magnum. It does all the configuration or setup to um, give you secure access to your cluster. The last point is something that is ongoing, and this is where we are adding auto scaling support for both container and host. Right. So with container, now we have a scaling that happened at the container level, and also scaling that happened at the cluster level. So we're trying to find a way to better coordinate that two level of scaling. Right. So how does Magnum fit into OpenStack? So here's one way to look at all the different services in OpenStack. So this is one way. I'm sure if you ask someone else, then they could have a different view. So at the bottom, you look at it, the OpenStack has a number of very basic infrastructure to support your compute. Namely, Nova give you the compute. Glance give you the image storage, and Keystone give you the authentication, the identity service. So those three layer form the very basic infrastructure as a service. Then you have a layer two where you add more infrastructure. So you have Sender for block storage, Swift, Neutron for networking, Designate for DNS, and Ironic for bare metal, and so on. So this is where you extend that the infrastructure as a service. And then the third layer, you have a enhancement like Salamana for monitoring, Barbican for secret storage, and Horizon for UI, and so on. So these are optional. You can install them if you want. And then at the fourth layer, this is where Magnum fit in. And this is what we call the consumption service, meaning that we are using the lower layer and offering a new service to the user. So here we have Heat for orchestration, and Magnum is a container as a service, and you have the other services there also. Okay. So how does Magnum bring container into OpenStack? So here you see a number of deep integration that Magnum provide. So at the top here you have Nova. Magnum allow you to use VM or bare metal to host your container. Magnum use Heat to orchestrate the whole deployment and management for your cluster. Use Glance to hold the image to launch your host. Use a Sender to as storage to host your container, and also as a storage to hold your persistent store data, so that you can reuse data. Use Keystone for authentication. Use Barbican to store the the certificate for your security, and use neutron extensively for networking. You create the network for the private subnet and router and load balancer and so on. It also used Talent for auto scaling. Touch up later. Right. Uh, Magnum offer a number of interface to the REST, so that the other service can use it. There's a REST API. There is a client, a command line client that talk to that REST API, so you can interact with it. And once you create your container, your cluster, then you also have the native client that come with the particular orchestrator engine. Okay. Now, how does Magnum work? So basically, there's a um, uh, cluster that you have to work with. A cluster is called a bay, and now before you create a bay, you have to create a bay model. A bay model is nothing more than a collection of parameter to that serve as your a template to create a bay. You can create model for a Docker Swarm, Kubernetes, or Mesos. Right? So that's the first thing you have to do. You have to create your bay model, and then from there you can create your bay. Um, Once you have your bay, then you can launch container on that bay. You can manage the container on that bay as well. Um, Magnum use Heat to perform all the orchestration. So basically, when you create a bay, it will launch a set of Heat template, and that Heat template will then create all the OpenStack resource and configure them, so on. So to bring the whole cluster up. So and then your cluster, it could be based on VM or bare metal. So here's what Magnum looks like, in terms of the operation. So on starting on the right side here, this is where the controller for Magnum it reside, and you see the two green box at the top there. The first one is the Magnum API. This is where you interact with Magnum, and the Magnum API has a number of concepts that we touched on the Bay model and the Bay before, and also the node. Uh, there's a couple boxes there that is now specific to Kubernetes, but that we're going to remove them because we want to make sure that the we don't replicate the interface from the engine. So things like pod and service and replication protocol, those are specific to Kubernetes. So we're going to remove them from the API. Now in the green box in the middle, that's the conductor. That's basically the engine for Magnum. We have a number of key templates that drive the orchestration, and we have handler for each of the particular uh, container engine, and there's a database to hold everything. So when you launch a bay, basically it's going to talk to Heat at the bottom there on the right side. Heat would take a template and talk to Magnum, talk to Nova, Neutron, Grand, Cinder, and so on, and create all the necessary resource to bring up the whole cluster. Now, if you look at the left side here, here is what a Nova instance will look like when it comes up, when it's launched from Nova. And at the bottom, you see the micro OS, and that comes with the image that we use to deploy Nova. There's a number of software also that come with that image. There's Docker, and then toward the top there you have Cloud Init, where we lay down the configuration for that particular Nova instance. On the left side there, there's a Heat config element. These are the Heat sub-config to do your software configuration, and basically it perform all the configuration for Docker and Flannel and etcd and so on. So once everything come up, then you have a Kubernetes Swarm in the middle there, and it run on top of Docker. And as you work and you launch a container, then the container Docker is going to be you know, kicking off those Docker image and so on, and run as container within the node. So that's the high level architecture for Magnum. Okay. Now, if we look at the what happened when create a different kind of bay, first is a swarm bay, and this is one of the kind of cluster you can create with the Magnum. When we create a swarm bay, you basically have a master and a number of nodes that would host your container. So for a swarm bay, you in the master you have a swarm, you run a swarm daemon, and then in each of the node you run a Docker daemon. That's how it works. Um, you see on the right side there, there's SCD that we use for discovery. This is when Magnum launched the cluster, it record the information on the cluster, on the node for the master and on the node in SCD, and then we use that to for discovery. And then there's a client that we use to talk to the swarm daemon to launch a container. Okay. Uh, for a Kubernetes bay, it looks a little bit different. And the high level structure is still the same, is in the sense that you have a master and you have a number of slaves that run that host your container. In the master, you have you keep API server, you have the scheduler, and you have the control manager. So these are the services that constitute Kubernetes. Um, in the node, you have kubeproxy, and you have the kubelet. Kubelet is the component that interface with the Docker daemon, and then they will talk to the kube API server. So when you use the Kubernetes client like kube control or the Kubernetes UI, it's going to talk to the kube API server, and then when you launch a container, then the container will be scheduled to the scheduler, and then it would be pushed out to the kubelet on the node, and then eventually the Docker would launch the Docker container. On the right side there, you see etcd. Here also we use etcd for discovery, and etcd is used both by Kubernetes and Flannel. And basically, all this it uses to hold the key value pair and share among the node. Flannel overlay is a networking that is used by Kubernetes. Basically, they provide a flat network space among all the containers in the node there. So that's how what a Kubernetes base looks like. Now, if we look at a Mesos base, and if you create a Mesos base through Magnum, again, you see a similar kind of structure where you have a master at the top and you have a number of node at the bottom, a slave. Now, Mesos work differently in the sense that in the master you have a leader, and you have a number of standby leader that as a leader may disappear, and then if that happens, then one of the standby leader would jump in and take over. Now in the node, you have the executor that would run a task, and you have a number of framework that get installed. Right? The framework is basically what the interface with Mesos, and it would request resource from Mesos, and then launch whatever application that need to run. Now, for us right now, we support Marathon as a framework. So Marathon is a framework for running long running application. And so in this case, what we would do is to run Docker inside of Marathon, and then once we launch that, then we can launch a container in Docker through Marathon. Okay. This is a view of what the networking looks like for a bay. In particular, this is for a Kubernetes bay. but the structure looks fairly similar for a swarm bay or a mesos bay. And, so here at the top you see a number of node, and they're labeled as master and the number of node, kind of similar to what we saw in the previous chart. Um, in the middle at the bottom here is what the networking looks like once we create all the neutron network and subnet and so on, and hook everything together. Each of the Nova instance would have a interface that connected to a private subnet, and that private subnet live in a private network, neutron network. Um, okay. Now, if you look at the bottom here, there's a public network, and this is where the connection to the external interface lives. The the private network in middle does not normally have connection to the external network, so we have to add a router. That's the component in the middle at the bottom there, and that router provides the path, the route between the private subnet and the public network. And okay, uh, so from a container that live inside one of the node here, it would go through the private subnet and go through the router and go out to the network. Now, on the other way in, we have a floating IP. Floating IP will provide access to the node so that you can log into uh, either the master node or one of the slave node. Okay. Um, we also have load balancer that provide load balancing for the services that run on the master node, and also for Kubernetes in particular. When you launch a pod, you can um, launch a service that come with that pod, and the service could have a load balancer sitting in front of it, so that the service for the pod can be exposed to the external internet, right? Okay, so we have been having regular release from as part of the OpenStack release cycle. For the Liberty release back in November, these are the key new features that were introduced. The first thing is that on the left column is the Mesos Bay type. Was the newly added in the that release cycle. Um, so with the Mesos Bay type, we launched Mesos along with the Marathon framework, and there is a REST API that comes with Marathon that you can use to interact uh, with the and launch container there. Uh, the second part, which is a very important feature, is security. Before that, we did not have security in the base, so that but now we have a security, the transport layer security, so that to access the bay, we have to have the proper certificate and so on. And the security happened at two levels. It happened both between Magnum and the bay, and also between the user and bay. Right? So, the third column there is the external load balancer. This is where we um, add load balancing to a Kubernetes service. And this is the way that you would expose uh, a service in Kubernetes to the outside world. What will happen is that um, we will add a neutron load balancer in front of it, along with the floating IP, and the load balancer will be automatically uh, update when you have change in the pod and the service in Kubernetes. And finally, we add the high availability for Kubernetes, in the sense that now we have multiple masters, and for that's in front of Kubernetes. And it also has a load balancer in front of it. Okay. Um, so these are the key new development that we are working on right now. So what I listed a number of you know, a project that we're working on in Magnum. And so the caveat is that what I listed is a bias to what I view as important. I'm sure if you ask someone else in the Magnum team, that they might show you a slightly different list. But these are the features that I feel are important. So first on the left side is scaling, and we touched on this earlier. What happened with the container is that we have a scaling that happen at the container level, in the sense that when your application has a lot of load, then you can launch new container to handle the load. Um, but we also have scaling that happen at the cluster level, at the bay level. Right? So in the sense that let's suppose you start your bay with five slave, five node, but later as you scale up your container, then you might find that your node are fully used up. Uh, so then you need to scale up your bay, adding more hosts to be able to host more container. Um, we do have support for this right now. The basically the engine would handle the scaling at the application level by launching new container. Then Magnum would handle the scaling at the bay level by using Salamander to watch the utilization of the uh, storage and the memory and the CPU on the node, and then you add more node or remove node as needed. So what we like to do is to have a better coordination between that two level of scaling, so that so we do a better job in scaling. Normally, things everything's okay if we have a lot of resource, but when we run out of resource, then this is where you have to make decision and, uh, and choose the right priority to allocate resource between the container and the cluster and so on. So that's one piece of work that's going on. The second column there shows container as a service, and so this is what we try to um, provide true container as a service from Magnum. Right now, a user would have to work with the infrastructure, meaning that we have to create a bay first and then launch a container on top of the bay. We want to be able to just allow user to walk in and launch a container without having to worry about the uh, what's supporting behind the team. And this is still work in progress. We're still trying to define what the API would look like and so on, what the user experience would look like. So in the third column is a persistent storage. This is a new feature that's been implemented for this cycle. So a lot has been implemented already, but we want to add more support there. And so the idea here is that normally container is ephemeral in meaning that once you start a container and you bring out a container, then everything is gone. All the storage from the container is gone. But there are use cases where you have to be able to save the data and reuse the data when you bring up the container again. And there are different volume drivers that are available to support this. And the driver provide different functionality. So, um, so here we are bringing that feature to the container environment. Um, the fourth column there is a new way to look at the container engine. So the way we work now is that you create a Kubernetes cluster or a Swarm cluster, and you would um, launch your workload in Kubernetes or Swarm in those ways. Uh, but we're finding that the user could have Kubernetes workload or Swarm workload, and they like to be able to use both of them at the same time. And so we were looking at um, doing this through methods. And the methods, the nice thing about the methods is that it give you, it allows you to support multiple workloads. So you could have both Kubernetes and Swarm running on methods at the same time. And it allows you to share the resource in very nicely. And the last column is networking. There's a lot of work going on right now, both in the Docker side and Kubernetes side to provide advanced networking. Initially, networking for container is a fairly simplistic, right? But now there's a lot of new work there where you can create network for your container and be able to connect to existing network and so on. So there's a lot of work there, and then we want to be able to bring those new features into to container through Magnum. Okay. So here's to give you a feel of what uh, the API looks like for Magnum. These are some of the commands that you can run with Magnum. Basically, here you see two concepts: the Bay model and the Bay. And Bay model, as we mentioned earlier, is a model or a template that contains a number of template parameters to create your Bay. Then once you have the model, then you can create your Bay. This is another set of API. This one is particular to a Swarm cluster. And once you create a Swarm cluster, then these are the kind of operation you can run against your cluster. You can create container, delete container, list container, look at the log, and so on. Okay. So Magnum run within OpenStack as two main services. So first one is the conductor, and as we saw in the earlier chart for the architecture, the conductor is basically the engine that run Magnum. And here we drive the heat template to create the cluster. We talk to the native client to create container, and we update once from time to time. The second service is the REST API, and this runs as uh, 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 this publish a REST API to the client, so that when you run the random client, it basically talk to the REST API. And if you build other service that talk to Magnum, then you will talk to Magnum through the REST API as well. And then finally, there's a command line client that you can run as a command line. For this cycle, there is new work for bringing Magnum to Horizon. There's a plugin now that you can install with Horizon, and it gives you the uh, the, uh, uh, the UI to interact with Magnum. Okay. So I'll try to show a demo then if we can bring it up. Right. So at this point, let me switch over and um, see if I can log into my desktop and show you some demo. Bear with me for a second here. I had everything working, but then my laptop crashed, so now I have to bring everything again. Okay, so if you see my terminal here, let me bring up another one. So this is a desktop that I'm running, and it has I'm running as a service there. Okay. So I'm running a command here, and maybe also connect to the screen for desktop so you can see what's happening in desktop.
Hey, Ton, can you zoom in just a little bit?
Okay. You want a larger font maybe?
Yes, please.
How do I do?
That's okay. That's okay. Please go ahead.
Okay. Yeah, I did this before, but I forgot how to do this. Okay. This right there. Right. So these are the services that run within the subnet now, and you see at the bottom, MCON is the Magnum conductor, and then there's API, that's a Magnum API. So if I do have a ray model already created here, so I'm going to look at it. So you see here, in this model here, I have a number of parameters set up. Like I'm using this key here. I'm using this image Fedora 21 atomic file. Um, I want to install Flannel as my network driver. And this is a Kubernetes cluster. And the flavor I want to use is small, and so on. So that's basically the template you want to use to create the bay. And I have already created a bay. So take a look at this bay. So this bay has this is the endpoint you can use to talk to your bay. Okay. It has one master right now and two nodes, and these are the two nodes that live in the bay. And you can log into those nodes to see what's going on. Okay. So here I log into the master node for this Kubernetes bay, and so from here I can run Q command to so kubectl is the command line for Kubernetes, and you can so from this point here, it behaves just like a normal Kubernetes cluster. So I can launch a pod here. Okay, just launch the pod. Okay, so that pod is being launched here. So here when I do get node, right now I have those two node that's running as my slave. Okay, so that's the command line. You can kind of see that. So now let me switch over and see if we can show you what the Horizon UI looks like. Okay, so I have to restart my. Okay. Yeah, so when my laptop crashed, it brought down the Horizon session. Yeah, I think we kind of run out of time, so let me skip that for now. Let me go back to which one here. All right, so sorry, I have to cut back on the demo. Now, if you want to build a dev stack with Magnum, there's instruction to do this, and it's actually quite simple. And there's a link in the chart. And so basically, when you build your dev stack, you just have to do a little bit of editing here to add to configure your dev stack configuration, and then you just run stack, and that will bring in the. What it does is that it pull in a plugin for Magnum that would do all the setup for you. And for security, we also use Barbican, so we also put in the public Barbican plugin, bring up the Barbican service. There's a manual step here that you can use to, if you want to do it step by step. So this might be helpful if you want to bring up Magnum in a standalone installation and not DevNet. So there's ongoing work to document the actual installation step for a normal standard OpenStack installation. So that is upcoming. Okay. If you'd like to contribute to Magnum, I have link for the bug here, and some of those bugs are tagged as low hanging fruit, meaning that they are easy bug to fix. So if you like to pick up something easy to start with, and then you can look at this low hanging bug fruit. Blueprint is what we're working on right now, and that give you a sense of what the team is heading, where the team is heading. And if one easy way to contribute also is just to review. There's a lot of patches right now that are open by the team, and you're certainly welcome to look at those patches, review them, and this is it's a good way to look at the code and understand what's going on there. For the next OpenStack Summit in Austin, we have a number of talks scheduled. We don't have a separate track for Magnum, but there's a number of talk related to Magnum in the container track. So if you come to the summit, then please look for us in the talk. And we also have our own design session. Normally we have about 10 design sessions. This is where we talk about the specific design topic for the next cycle. So this tend to be very deep and technical. Okay, so just a bit of a statistic about Magnum. As I mentioned, this is about the project is about just about a year old, and what's interesting here is that we do have quite a bit of participation from many different companies. 34 different companies participating right now, and about 133 developers. A lot of code has been added in last year, and the last release was just back in actually the years wrong. It's 2006. Okay, and some more statistic on the company. And IBM happened to be the top contributor for Magnum for the last 2 cycles, and I think we'll continue on going forward. I think we'll continue to be the top contributor for a while. So that's all we have. Any question?
Question. Yes.
Yeah, it's a little hard to hear, so maybe Nikhil can relay the question.
So I have a question. You started out with talking about the pros and cons of using a direct Nova driver for something like Docker or other container technology. And then obviously the advantage of using Magnum as a orchestration framework to create clusters, right? Is there any reason to use both? And would there be any conflict if you're using Magnum and a container driver from Nova?
No, you can certainly use both. In fact, one of the use cases that has been talked about is to as you saw right now, you can create a cluster with VM and bare metal, and you could also envision create a cluster data host by container. So you would have container running with a container, and that might sound strange, but actually it's not it could be advantageous to you. And the overhead is not something that we have to worry about. So it might make sense to actually have uh, Docker Nova, the Nova Docker driver, and use that as uh, the target for your cluster.
Yeah, so the use case I was thinking is kind of a kind of some services that would run OpenStack that use just containers, but are self-contained services. They don't need to be very large clusters, so I don't think they need the overhead of the whole orchestration of creating cluster and stuff like this. We're just using containers as a easier way to get some of these services up. But then, having clusters managed by Kubernetes or Mesos for larger running workloads, but have them coexist. So, in your opinion, that wouldn't be there wouldn't be any conflict between doing those two at the same time.
No, I think that's a perfectly fine example of how we can mix and match. Basically, the idea is that you can run your container anywhere, and with the new support now for networking, we should be able to bring them together and have some workload running on the Nova Docker driver, some workload running on Mesos, and some workload running on a standalone Kubernetes cluster, and be perfectly fine.
The second question I had is, there was a recent announcement that Google was putting more weight into getting Kubernetes to be a first-class citizen for OpenStack. Is that related only with Magnum or with something else? Are you aware of that?
Can you repeat some of that? You said that Google is.
There was an announcement that Google was putting more weight into getting Kubernetes to be a first-class citizen into the OpenStack project. Is that exclusively, working with Magnum, or is it at a different level? Are you aware of that?
Yes, so we as a Magnum team, we heard of that announcement as well, but we have not seen new contributor from Google joining Magnum yet. So we haven't quite seen the manifestation of that announcement.
But you already have some contributors from Google, right, on your project?
Right now, no, I have not seen contributor from Google yet. Now we do work with them closely, and we talk to them regularly on the RSC channel and ask questions and get advice and so on. So we work with them in that capacity, but we're still waiting to see whether Google will have a developer joining Magnum project.
So most of the integration with Kubernetes here has been done by whom? By IBM?
Right. So as you see on the chart, this chart here on the on the contributing publisher. So IBM certainly does a lot of that work, and Rackspace also is making up the contribution, and Huawei as well. So Cisco used to do a lot of work with the now they see the backup.
But specifically to Kubernetes, who is the biggest contributor, having done most of the work?
I would say, among the three top companies there, IBM, Rackspace, and Huawei, it's pretty much a share kind of interest there. So everyone, felt that Kubernetes is an important container engine, and we spend a lot of time on that.
Okay. Thank you.
Okay.
Any other question?
I guess that's it, Ton.
Okay. Thank you, everyone.
Yes.
Okay. Bye bye.